Let's start with the easy one then. Okay, so a particle moves along a horizontal line so that its acceleration t is given by this formula, and suppose that the velocity of the particle at t of 0 is 3 meters per second and the position at t of 0 is 4. Find an expression for the position. All right, not a hard question, because if you look at the acceleration equation, there is only t. Right, so we've been kind of doing separation of variables, which means that in that equation there is both x and y, and then so you have to do something with separating them. This one doesn't even have to separate. There is only one variable. If you need to separate, then in the equation itself, we'll probably have something with like v. But there's nothing. So it's just a very straightforward integrate, plug in initial conditions, and that kind of stuff. So let's just kind of review. So go ahead and figure out what is the position formula. Let's call it S of t. So go ahead and do that. Let me know when you're done. Okay, so S of t is equal to t cubed over 3 plus 3t minus cosine t plus 5. All right, now that's kind of just the review stuff. Let's go ahead and do the next one. This is the harder stuff. Consider the differential equation dy dx equals 2xy. So you can see why, bless you, this is the differential equation where there is both variables in there. We're going to have to separate. Let y equals f of x be a particular solution to this differential such that f of 1 is equal to 3. Meaning that f is y, and then so f at 1, meaning y at 1 is 3. So when x is 1, y is 3. First, find d2 or d squared y dx squared, or second derivative. So you need to take that first derivative, find another derivative, which you need to kind of think back about last semester, implicit differentiation. Y has something of x in there. We're going to take the derivative, but you need to remember that because y has something in there, we got to do chain rule. Okay, so you probably forgot how to do implicit, so I'm going to just remind you. Okay, so 2 over xy, you should change everything to an exponent instead of leaving in a denominator. It's much easier to do it that way. And then we're going to take the next derivative. So we're going to take one derivative on the left. That's going to give us second derivative. Take the derivative on the right, which is a chain rule. Product rule with a chain rule. Okay, so second derivative. All right, box and triangle, if you forgot. 2x to the negative 1. What is the derivative of y to the negative 1? No. That's the integral of it, but the derivative.
Negative y to negative 2.
Negative, okay, so negative y to the negative 2, because put that negative 1 in the front, y to the negative 2. Now, y has something with x in there. Therefore, dy dx. Okay, please make sure you see that part, because y is always a variable in terms of x. On the test, they probably will not do an x and y because that's too easy. They'll probably do something like n and x or q and t or something like that. Please be careful. All right. Now, product rule. So box, d triangle, triangle, d box. Okay, triangle, and then derivative of the box. What is the derivative of 2x to the negative 1?
Negative 2x, negative squared.
Yep. So negative 2x to the negative 2. There is no chain rule, or if you want to do chain rule, you could. dx is just 1, so it doesn't really matter. Okay, at this time, combine everything together. Please be careful. I would probably change everything to fraction form, so it's more, so there's less like negative signs floating around. Okay, so something like that. Now, remember in that section we had the implicit differentiation. There was a trick. dy dx. Does dy dx come up somewhere in the question?
Oh, yeah.
Yes. we have to substitute. Okay, so dy dx is 2 over xy. We got to substitute that back in. So negative 2 over xy squared. 2 over xy minus 2 over x squared y. And at this time, just clean everything up. Negative 4 over x squared y cubed minus 2 over x squared y. Gonna multiply y squared here. So that is negative 4 minus 2y squared over x squared y cubed. Yeah. All right, so this kind of question, they most likely will give you something like that. They give you a derivative, and they want you to find the second derivative. You gotta have to use implicit because now you have x and y together. Okay, and this would be kind of the easier kind. The harder kinds will have something like, they will say n of x is equal to blah, blah, blah. And then all the, you're not used to seeing anything besides dy dx, then it gets a little bit tricky, okay? But it's the same thing. All right, so that's that. Next, write an equation for the tangent to the graph at 1, 3. Use this tangent line to approximate the value of f of 1.2. All right, another thing you have to remember from first semester, linear approximation. So, tangent line to the graph. What are the two things you need for a tangent line?
Slope and position?
Yes, slope and position, or slope and a point. Okay, so we need a point, which is 1, 3. We need the slope at that point, which is f prime at 1. How are we going to find f prime? Yes, f prime is the derivative of f, which is the derivative of y, because they said y is f. Right? So then what's the derivative of y? dy dx. Okay? So the slope is 2 over xy. And we have the point. So then we have to do that. Go ahead and figure out the tangent line. Okay, so the slope is 2 over 3. You got to write the equation of the tangent line. Y minus y1 equals m times x minus x1. Okay, you should get the equation y minus 3 is equal to 2/3 x minus 1. Now they want you to use this line to approximate f of 1.2. F of 1.2 means x is what?
1.2.
Yes, 1.2. So we want to figure out f of 1.2, meaning y. What is y when x is 1.2? Okay, so basically solve that, and then that's going to give you the y at 1.2 according to your linear line approximation. Okay, and y should be 47 over 15. Okay, if you use your calculator, then you have to check to see if you have the same numbers. All right, last one. This is kind of the hard one. Given that f of x is greater than 0 on the interval between 1 to 1.5, determine whether the approximation in part B is an underestimate or overestimate. Explain your reasoning. Okay, what does f of x greater than 0 mean? What? Y is greater than 0, which means what?
It's only positive.
It's only positive. So basically the graph is above the y-axis, x-axis. So your graph is like this. That's what it means. Between 1 and 1.5. So beyond 1 and 1.5, we don't know what's going on, but at least between 1 and 1.5, it is positive. Okay, determine whether the approximation in B is an underestimate or overestimate. So we were trying to create a line that is tangent to 1 and 3, right? So we know that the graph crosses at 1, 3, and then we created this line like that. The question is it an underestimate or overestimate of 1.2? So meaning at 1.2, is this point above the graph or is it below the graph? Because I don't know how the graph looks like. what is the important factor to determine whether this is going to be over or under? Because the graph could look like this, and then your line will be under, or the graph could look like this, and then your line is over. So, what's going to determine whether your line overestimates or underestimates? Yes, very good. Concavity, right? You can see the only difference between those two graphs is the concavity. One points up, one points down. So you need to figure out what is the concavity at 1. If the graph is concaving up, then you know you're going to underestimate. If your graph is concaving down, then you're going to overestimate. Okay, how do you figure out the concavity at 1, x equals 1? Yes?
What would it be? d2y over dx?
Yes, use the second derivative, which you found in part A, right? So use part A to figure out what's going on at 1, 3. Okay, go ahead and do that. And there is a reason they tell you that f of x is greater than 0, right? They want you to use positive numbers because, or else there may be 2 possibilities. Okay, so is the second derivative positive or negative?
It's negative.
Negative. So is that going to be an overestimate or underestimate?
It's an overestimate.
Overestimate. So when you write your explanation, you're going to say, what is it? The approximation is an overestimate because the tangent line is above the graph because the graph is concaving down according to second derivative test. Something like that. You got to put all that in there. Your reason and fact. What proves your reasoning. All right, so that was a difficult question. Let's try another one. This one should be a little easier now that you're more used to this kind of question. The tree farmer in upstate New York plants a seedling. Seedling is like a little tree, like a small tree, for a 1-foot tree at time t equals 0. If h of t is the height of the tree in feet at time t years after it is planted, the rate of growth is proportional to the difference between its maximum height, 10 feet, and its current height given by this. Okay, so this is a typical differential equation where your equation now has an h in there. Okay, no longer is it only t, the variable is also in there. So you're going to have to separate. If you want to integrate, you have to separate. Is the tree growing faster when it is 2 feet or when it is 4 feet? Explain your reasoning. All right, talk to your partner. What are they looking for? What does growing faster mean? All right, what does growing faster mean? What are they looking for? dh over dt, yes. They're looking for dh over dt at 2 compared to dh over dt at 4. So what is the rate at 2? What is the rate at 4? Okay, so then you're going to, do that and then explain which one is bigger. That's going to tell you at what height is it growing faster. Okay, so what is the rate at 2? Nobody finished? Not yet. Okay, rate at 2 is 6 over 5, and a rate at 4 is 9 over 10. So which one is bigger? 2. So then you're going to explain something like it's growing faster. Okay. It is growing faster at h equals 2 because h prime of 2 is bigger than h prime of 4. And that should be sufficient to explain. All right, next. Find the second derivative in terms of h. Use this expression to explain why the graph of the solution curve is concave down. Okay, find it first, and then we'll talk about the explanation. Okay, so this is kind of the question that they will ask, where, h is somewhere in there, and now it's a little bit tricky. Okay, so we know that dh dt is this whole function up here. If you're not used to take a derivative of that, you should probably multiply it out, so it's easier. Okay, dh dt is 30 over 20 minus 3 over 20h. Okay, so taking this next derivative, so second derivative, that constant is going to go away. It's negative 3 over 20 times h prime, right? The variable is, the ultimate variable is t. H has t in it. So when we take the derivative of negative 3 over 20h, you take the constant and then take the derivative of h. The derivative of h is dh dt because that whole thing has a t in there, so we got to do some chain rule. Okay, so you're probably not used to this h be prime because it's not in the question, so dh dt. Okay, so that is negative 3 over 20, and then dh dt is 3 over 20, 10 minus h from the question. Okay, so this is negative 9 over 400. 10 minus h. Okay, so this is the second derivative. At least have that. That's going to give you some points. Next, explain why this graph is always going to concave down. So we have to go back to the question itself to look at the clues. The clue says this tree is going to have a maximum height. Well, first of all, when you first plant this tree, how tall is it?
0.
1 foot.
Yeah.
What's the highest height before you cut it off? 10. So it's only between 1 and 10. So then you ask yourself, when h is between 1 and 10, what kind of numbers are you going to get out of this second derivative? Negative. It's always negative. Because this part is always positive, right? Between 1 and 10, this is always positive. This part is always negative. Therefore, this is always negative. So then you're going to explain this is concave down because this is always negative between 1 and 9. So this is always negative between 1 and 9. So this is kind of tricky. You got to go back to the original question and look at the requirements. And these are not written out for you anymore. It is in the wording itself.
Shouldn't it be not like greater than equal to, just be less than 10? Not equal to?
Oh, I'm sorry. Why did I put 9? I don't know. I'm going to say that both of them are going to be acceptable. Yeah. All right, so that's the second question. Next. Okay, find the equation of the tangent line, blah, 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 and explain if it's an overestimate or underestimate. You should be able to do this now. Go ahead and do that. All right, so they want you to find the tangent line at t equals 0. So at t equals 0, the tree is 1 foot tall. So what you want to do is figure out what is the derivative at 0, which turns out to be 27 over 20. So then if you write the equation, it's y minus y1 equals m times x minus x1. So this is y minus 1 equals 27 over 20 times x minus 0. And they want you to use this line to approximate what happens at x equals 1. So y minus 1 is equal to 27 over 20 times 1 minus 0. So then y turns out to be 47 over 20. Okay, you want to, again, answer whether this is going to be an overestimate or underestimate, and this has to do with the second derivative. So at the second derivative, you want to plug this in and check to see what is the sign. Okay, at second derivative, this turns out to be negative. So it's another concave down, which means the line is going to sit on top of it. This is going to overestimate. Okay, Okay, next question is more straightforward. You just need to find a particular solution to this differential equation. So the same thing we've been practicing the last 2 days, you're going to take the integral. Finding the solution to this differential equation means find the integral with the initial value h of 0 is 1. So just take the whole problem, make sure you separate it, h goes on one side, t's go on the other side. So dh over dt is equal to 3 over 20, 10 minus h, so move all the h to one side. dh, and that's 1 over 10 minus h equals 3 over 20 dt. Okay, and then solve that with the initial value of h of 0 is 1. Let me see. H is equal to 10 minus 9 e to the negative 3 over 20 t.